Hi there. Purpose of this video is to modify the internal resistance of a signal generator which has nominally 50 ohms internal resistance with a 10k pot. So what we're doing is modifying the internal resistance so that the pot defines the internal resistance based on where the pot setting is connected to a decade box, which is our load. So when we connect the pot in and we set it to 100%, which is 10k value, we leave the circuit open circuit. There's no decade box R load connected. It's effectively an open circuit seen by the signal generator, and we'd expect the full 20 volt peak to peak out 1 kilohertz, which is what is going in from the signal generator. When we set the pot setting to 75%, we've effectively got a 2K5 in parallel with a 7K5, which R load, when we connect an R load in, looking backwards, or from right to left, the R load will see an effective equivalent circuit of 2K5 and 7K5 in parallel, which will be 1875 ohms. If we set 50%, the R load looking back will see the equivalent of 5K and 5K in parallel, which is 2500. 25% setting, they will see 7K5 and 2K5 in parallel, which again is 1875 ohms. So 75% will be 15 volts peak to peak, out open circuit. 50% setting on the pot will be 10 volts peak to peak out, and 25% setting will be 5 volts coming out open circuit. This is a modified half voltage test. So for example, at 75% we'll have 15 volts coming out open circuit. If we connect the R load box in, what we're looking for, half voltage, half of 15, 7.5 volts peak to peak. When we get 7.5 volts peak to peak, we know that we've got half the voltage out, we've got a voltage divider, and the load resistance at that point will equal the internal resistance of the circuit, and we would expect in the region of 1875 ohms. 50%, for example, open circuit is going to be 10 volts peak to peak. So when we connect our R load box in, when we get half the voltage out, that would be 5 volts peak to peak. We would expect in the region of 2500 ohms on the R load box to get half the voltage out. So those are the theory calculations based on nominal values. Let's see what happens in a real circuit. So at the moment we're going to turn the pot round to 10k, and what we can see here, 20 volts peak to peak coming out. It doesn't matter whether we've got the R load box connected or not, really, it's only making a tiny difference. We've got an open circuit at 20.4, and that would be what I expect. We get the full voltage out. If we turn the pot down to get 75%, which is 15 volts compared with the original 20, there's 15 volts out. That's the open circuit voltage at 75%. We don't have the R load box connected in. We'll connect it in now, and what we're looking for coming out is 7.5 volts peak to peak. So we need to turn our R load box down. That's 3k, not quite there. 2k, we're getting there. 1k, we've gone too far, so we need to turn the hundreds back up. So we go 1100, 1200, we're getting there. 1400, 1500, 1600, 1700, 1800, we're just about there. 1900, kind of overshot. If we set it to 1800 and we look at the tens, can we get 7.5 volts peak to peak? There's only a resolution there, it's jumping 0.2 volts. If we turn up there, it starts to jump up to 7.4, 7.6 is jumping between the two. So we'll call it there, and what we're getting on the decade box is 1860 ohms to give us half voltage compared with our 15 volts out. So that's open circuit 75%. We now put the load in, and the load at half the voltage, 7.5 volts, is telling us that the internal resistance is 1860, which matches with the theory of 1875. So that matches up the theory. Take the decade box out, so it's now open circuit again. We go down to 50% open circuit, which is 10 volts, peak to peak, which is there. And what we're looking for on the box, half voltage test when we put the load in, is half of 10, which would be 5. So we've got 4.6 there, which is too low, so we go back up. So that's 2,800. We've got 5.6 there. We're looking for half, which is 5. We go down a bit. We go down. We go down. And we've got, we'll change the 10s to, we'll go to 0, so we get an approximate figure. So we've got there, that's 5.25. It's flicking between the two, and what we've got on the box is 2,400 ohms. The theory says 5k and 5k in parallel, 2,500, and what we measure is 2,400, which is pretty close with an experimental uncertainty. What we're going to do now is 25%. We go open circuit again. We turn down the pot setting to 25%, which is 5 volts peak to peak on our dial there. 5 volts peak to peak. That will be there. So we've got 5 volts peak to peak. What we're now looking for is half voltage test. So we're going to set the load box to get half of 5, which is 2.5 volts peak to peak. We've still got 3 volts there, so we're too high. If we bring it down, we've got 2.4. We need to go back up to, 2.6 there. So what we're getting there, there's not much change in those settings. It's gone up to, it's gone back. That's 1900, it's 2.8. 1800, 2.6. Yeah, so we're there. So we're looking on the decade box, we're now getting 1700 ohms. So on the 25% setting, we expect 1875. We're measuring in the real world 1700, a little bit lower than expected, but it's within experimental uncertainty. So what this video is showing is how you can modify the internal resistance of a circuit with a 10k pot, and doing the half voltage test again at 75%, 50% and 25% to measure the internal resistance on a real circuit. Thank you for watching.